Hello, everybody. What we're going to do right now is go over the 1.1 test review. So right here on this page, you'll see everything that you need to know in order to complete this test successfully. So let's just jump right in and get to problem number 1. So what we want to do for question number 1 is start by reading the problem. The first thing that we're going to talk about is the first sentence. It says, a flat surface is an example of a blank. Well, we can think of a flat surface as like a piece of paper. And a piece of paper is actually representative of a plane. So let's write that word down in the blank and we can cross it off of our word bank. Now we are going to read the following sentences, and we're going to start by highlighting the keywords that we see. The first word that I see is turning. That tells me that this transformation has to be a rotation. So let's write that down and cross it off our list as well. Another keyword that I see is the word sliding. And we should know that a slide is a translation. So we write the word translation in the blank. Finally, I see the keyword flipping, so I'm going to highlight that as well. And we know that a flip is a reflection. Now, this last sentence I'm highlighting right now talks about 3 specific types of transformations. Each of these transformations has one thing in common. They are rigid motions. And rigid motions, by definition, are just transformations that do not affect the shape or the size of our object. So let's write that down here. Now let's move on to the next question. Question number 2 asks, what's the only transformation that does not preserve distance? Well, first we need to know what preserve means. I'm actually going to highlight this word for us so we know that this is a vocab word. Remember, preserve means to keep the same. And in fact, the dilation is the only transformation that does not preserve distance, because a dilation does in fact affect the size of our segment lengths. It affects the segment lengths because a dilation, by definition, is an enlargement or a reduction. That basically means we're making something bigger or we're making something smaller. Think about it this way. If I were to take one triangle that has a length of 3 and I wanted to enlarge it and make it 2 times bigger, then my segment would now be 6 units long instead of 3. That's why a dilation does not preserve distance. And so now we're on to question number 3. Question number 3 asks us, what is a scale factor that can be used to dilate QS to create QR? The formula that we're going to use to help us right now is new over old. That means we are going to find the length of the new segment, QR, and we're going to find the length of the old segment, QS. we can find the length of each segment by counting the boxes. So if we count all of the boxes from Q to S, we'll have 14. If we do the same thing with Q and R, we have 4 boxes. Now we are going to set up our equation to put the new, which is 4, over the old, which is 14. We're almost done here, but our last step is to reduce this fraction. So we're going to find a number that both the top and the bottom can be divided by. Both the top and the bottom can be divided by 2, so this leaves us with the reduced fraction 2 over 7. And that is the answer. Now let's move on to question number 4. Question number 4 tells us that points A, B, and C are collinear. Collinear is actually a vocab word that we should probably highlight. Collinear basically means that points A, B, and C lie on the same line. So we need to draw a line with 3 distinct points on it. This next sentence is key because it says point A is in between point C and B. That means that we're going to write point A in the middle of our segment with C and B on the opposite sides. Now that we know that, we're going to look at the information that they gave us. They tell us CB, from here to here, has the equation 17x plus 28. We're going to do the same thing for BA. BA is the distance from point B to point A, which has a length 14x minus 3. Same thing for CA. We're going to write that equation, 8x minus 4. Now we have our diagram completely labeled. Our next step is to set up the equation that says a part plus a part equals the whole. In this case, 8x minus 4 is a part. So we're going to add that to 14x minus 3 and set both of those equal to 17x plus 28. Our next step is just to solve for x now. So we're going to start by combining like terms where we can. We're going to take the 8x and the 14x that we see, we're going to add them together to give us 22x. We could do the same thing for the negative 4 and the negative 3 to give us negative 7. Then we're going to bring down the 17x plus 28. Now that we have this equation, we are going to start by subtracting 17 on both sides of our equation. (22x minus 17x is 5x, so that's the only thing that changes here. We're just going to bring down everything else that's left. Now that we have this, we're going to add 7 to both sides to further isolate the variable. 28 plus 7 is 35, so this should leave us with 5x equals 35. Our final step here is to divide both sides by 5 to give us x equals 7. Now that we know that x equals 7, we're going to use that information to determine if A is the midpoint of CB. We are going to do that by plugging x into each of these equations. So let's start with CA. CA is 8x minus 4. All we're going to do is replace the x in this equation with the number 7. So this becomes 8 times 7 minus 4. 8 times 7 should give us 56. And 56 minus 4 is 52. So the length of CA is 52. Now let's do the same for BA. BA is 14x minus 3. So we're going to replace the x with a 7 once again, giving us 14 times 7 minus 3. In this case, 14 times 7 should give us 98. So we end up with 98 minus 3, which equals 95. So what we're going to do now is we're going to take the fact that CA is 52 and the fact that BA is 95, and we're going to make
Since 52
is not the same as 95, our answer is going to be no. A is not the midpoint of CB. And it's not the midpoint because CA has a length of 52 and BA, on the other hand, has a length of 95. And that right there is our answer. So let's move on to question number 5 now. Question number 5 wants us to fill in the blanks to complete the statements about the graph that we see on the left-hand side. If we read the first statement, it says figure 1 and 2 are blank. Well, figure 1 and 2 are exactly the same, which means that they must be congruent. And if you look carefully at what's happening in figure 1 and 2, you'll notice that all we did here was slide our figure up. A slide is just a translation. So a translation is the transformation that happened here. Now let's look at figure 2 and 3. Figure 2 and 3 are going to be similar because they're not entirely the same. Both 2 and 3 have a different size. And in fact, the only transformation that changes the size of something is a dilation. So those are the words that fill in the blanks. Let's move on to question number 6. In question number 6, you'll notice we have 3 expressions. First thing we should do is label our figure with the expressions that they give us. The first one we're going to start with right now is HY. HY in this case is 6y plus 22. And that is the right-hand side of this figure. HK has the expression 9y plus 4, which represents the left-hand side of this diagram. If you look carefully, you'll notice that this diagram is one large triangle that's been split exactly in half. That means that the left-hand side must be equal to the right-hand side. So we're going to set up an equation that says 9y plus 4 is equal to 6y plus 22. Now it's just our job to solve for y. So we're going to start by subtracting 6y from both sides of our equation. This leaves us with 3y plus 4 equals 22. After this, we would subtract 4 from both sides of our equation, leaving us with 3y equals 18. The final step should be to divide by 3 on both sides, leaving us with the fact that y equals 6. So now that we know that y equals 6, we can move on to the next part, which is to find the length of ky. Ky has the expression 15y minus 3, so all we're going to do is plug it in like we've done before. So this becomes 15 times 6 minus 3. 15 times 6 should be 90. And 90 minus 3 is 87. So ky has a length of 87. And that's it for number 6. Let's move on to problem number 7. For problem number 7, it's important that you recognize this diagram as the construction for copying a segment. Now, whenever we copy anything, basically we're making a replica of it that is identical or the same as the original. When two things are the same, that means that they are congruent. So for part B, we should write the congruent symbol in the middle of this statement. So now let's move on to question number 8, the last question. For this problem, what you need to do is to read through each of these steps and to put them in number order. Personally, when we're going about constructions, it's always best to start backwards. What we need to do first is to recognize what type of construction this one is. And this is actually the construction for creating an angle bisector. So at the end of this construction, we should have created two angles that are congruent to each other. For this same reason, we know that the statement that says angle ABL and angle CBL are congruent angles should be number 6. We're going to continue to work backwards from there because before we can know that they're congruent angles, we have to draw our angle bisector. In the case of our picture, our angle bisector is the line BL. That's why this is step number 5. And when we continue to work backwards from there, we can obtain all the steps in the correct order. And this is how we complete problem number 8. This brings us to the end of our test review. I hope you all enjoy and happy studying.